guys, so here are our plans for today. Here's our agenda. First, I need you guys to write down the word of the day. I'm actually going to show it in here in just a second. Then I want to talk to you about the density hands-on practice that we did last class, and then tell you what you need to do if you didn't get it finished last class. Also, I think that some of you guys might want to do some corrections to it. So the supply boxes are over in Mr. Deal's room next door, just across the hall. So if you need to grab a supply box, you guys can go over there and grab them. Remember to be quiet and respectful when you go into his room while he's teaching. And then if you need to make corrections to your paper before turning it in, you can do that. Finally, I have some density practice problems for you to work on during class today, and so I do want you guys to take your time working through those. I'll show you a couple of examples here in just a minute, so it should be pretty easy. Okay, then the last thing we'll do is the daily quiz. So at 1 o'clock, Mr. Scharnhorst is going to show you guys the daily quiz, or give you the access code to get into daily quiz 13. Now, please remember to be kind and respectful to Mr. Scharnhorst. He's an awesome teacher, and he actually used to teach here at BLHS, so he knows not to put up with squirrely behavior. All right, so for your word of the day, it is the word element, and so you guys are going to need to write down the definition of element. And then for your density hands-on practice, I want to show you guys my example chart. Now your chart might not be exactly the same because of your particular masses and your measurements, but some things I want to point out. Okay, for your, actually let me make this bigger so you guys can actually see me. Okay, so on here, notice that all of my mass values are the same. So you guys should have found that your masses were the same mass, or at least very, very close in mass. Also, notice that my volumes increase in size. All of these masses, this is the order of them from smallest to largest, and so your mass volumes should be increasing in size. So that first one says 5.0, 7.0, and remember we're measuring 2 sig figs on these. Okay. And then if you have a volume down here that is actually smaller than one that's up above it, that means that you need to do some remeasuring. Then for your densities, notice that my densities are all decreasing in number as we go down. If we're taking the same number and dividing it by a gradually larger number, then we should be getting densities that are smaller. Okay? So please make sure that you check those and that you have grams, milliliters, and grams per milliliter labeled in your table. Now for the graph, first thing that you're doing is you're listing those values. Now I have the milliliters and grams per milliliter listed at the top of the table, so you don't have to list them down in here, but you do need to list your volumes and densities again, exactly what you had on the top down here. And then we should be graphing those. So we're graphing volume versus density. Density is on our y-axis and volume is on our x-axis. Because what we're actually changing in our experiment is we are changing what volumes we're looking at, and then we're seeing how that is affecting the density. And something that we're keeping constant here is the mass. Okay? So the thing that I'm changing is volume. The thing we're keeping constant is mass, and the dependent variable here is density. And please make sure that you're numbering your x and y axes appropriately. They should be numbered from 0 to whatever the biggest value is that you need to measure. My biggest volume was 23, so I numbered by 2s, so I could go from 0 to 24. And then for my densities, my biggest number was 13. So I numbered by 2s again on the y-axis from 0 to 14 so that I would have enough space, and then plotted those points. So please make sure that you check your work on there before handing it in. Next we have the practice problems. So if you guys will take a look at the practice problem sheet. Here is our practice problem sheet. Let me scooch it over so you guys can see it. Here we go. Notice on the front page there is a triangle for you guys to fill in, just like we had on here. So you guys can be filling in the mass on top, and then the D down here, and the V over here, and our formulas for density, volume, and mass. I've got a couple examples for you. You should be able to get them all from the examples down here. So we have, in our first example, a block of aluminum occupies a volume of 15 milliliters and weighs 40.5 grams. What is its density? So that means the formula that I need, the equation that I need, is D is equal to M over V. That's density is equal to mass over volume. Then I'm going to substitute in my numbers. So my density is equal to mass divided by volume. So on top here, I put my mass, which is 40.5 grams. And then I put my volume on the bottom, that's 15.0 milliliters. And then my final answer for density is 2.70 grams per milliliter. Notice that my answer has the same number of sig figs that I started with. Okay, so keep those sig figs consistent. Now, in our next one, we have mercury metal is poured into a graduated cylinder that holds exactly 22.5 milliliters. Mercury has a density of 13.6 grams per milliliter. What must be the mass of this amount of mercury? Okay, so we have mass is equal to density times volume multiplied together. So you're going to write in this blank the density, which is 13.6 grams per milliliter. So you're going to copy exactly this into the blank here. And then for the volume, you're going to write 22.5 milliliters in the blank here. Then you're going to actually multiply those numbers together, and then your final answer needs to be rounded off appropriately. So if I do 13.6 grams per milliliter times 22.5 milliliters, okay, equals, notice that that says 306 exactly. How many sig figs is that? Well, that's 3 sig figs because the 0 between the 3 and the 6 is considered significant because it's between. So you would just need to put 306 and then our unit for mass, which is G for grams. Okay? And then notice that number 3, you have the equation for volume this time. Volume is equal to mass divided by density. You're given a mass and you're given a density. So you should be able to figure out the volume of this substance. Okay? Now, the next one here, this actually, instead of giving you milliliters, it gives you centimeters. And something about that you need to know is that cubic centimeters or centimeters cubed is the exact same thing as a milliliter. They are the exact same amount, and that's done on purpose, actually. 1 milliliter is the same as 1 cubic centimeter. So the first thing that you need to do for this problem is figure out the volume of the block in cubic centimeters. You do that by taking the 3 dimensions, the height times the width times the depth, and getting that volume. So I would just do 8.4 times 5.5 times 4.6, like that. Enter. And we get 212.52. So that value is not 2 sig figs. So that means we need to round this off. If I round this off to just 2 sig figs, we have to round it off after the 1. And so if that's a 2 behind the 1, should we round it up or keep it the same? We should keep it the same. So that answer should be 210 centimeters cubed. So you're going to write 210 centimeters cubed. Oops. There we go. 210 centimeters cubed in for your volume. And so then when you come down to do your actual density calculation, this is the number that you're going to need to use. And now your final answer, this has 4 sig figs here, but since we only have 2 sig figs in this number, your final answer can only have 2 sig figs as well. Okay, so make sure that you only have 2 sig figs in this final answer down here. Okay, on the back side, you still have the place for the equation, the substitution, and your final answer, but I have not written the equations in. So you need to look at the question and figure out which formula you're supposed to use. If there are other places where you have to do any math before doing the actual equation, like we did here, where we had to find that volume first, I have given you a hint to make sure to do that, okay? So there, you're doing that in number 5, as well as in number 8. You have to figure out the volume first. We're going to do that multiplication thing again. And then here you do have to find a volume here. This is finding volume in a graduated cylinder. So it's just like what we did in our lab where you had 20 milliliters of water already in there. So we had to subtract 20 from whatever volume we measured when we put the objects into that cylinder, okay? All right. So that is what I need you guys to work on today. If you need help, Mr. Scharnhorst can help you out. And if you do not finish your practice problems in class today, they are due at the beginning of class on Friday. Okay, that's it. Thank you guys.